We're going to solve radical equations. Solving a square root equation may require that you square each side of the equation. This can introduce what are called extraneous solutions. An extraneous solution is a solution derived from the original equation, but is not a solution to the original equation. So in other words, you solve an equation for x. You go through all the right steps to solve for x, and then you get the solution. But when you put it back in, it doesn't work. It doesn't make a true statement. That's called an extraneous solution. To solve a radical equation, you want to isolate the radical to one side of the equation, then raise each side to a power suggested by the index. So for example, if it's a square root equation, you'll end up squaring both sides. If it's a cube root equation, you'll end up cubing both sides of the equation. I'm going to solve this equation for x. 3 plus the square root of 2x minus 3 equals 8. I'm going to isolate that radical to one side of the equation, move everything else to the other side. So we're going to move that 3 to the other side by subtracting 3 from each side. When you do that, get the square root of 2x minus 3 equals 5. Now we want to get rid of the radical sign. You want to do the opposite of square root, and that is squaring both sides. So if you square each side, if you square the square root of 2x minus 3, that is 2x minus 3. And on the other side, if you square 5, that is 25. Add 3 to both sides, get 2x equals 28. And then finally divide each side by 2, x equals 14. But we did square both sides, so that could have introduced these extraneous solutions. So you want to check that solution, put that back in, make sure it does make a true statement, make sure it is a solution. So you're going to substitute 14 back into that equation for x. You have 3 plus the square root of 2 times 14 minus 3 equals 8. So multiply 2 by 14, that is 28. So 3 plus the square root of 28 minus 3 equals 8. Well, 28 minus 3 is 25, so it'd be 3 plus the square root of 25 equals 8. And the square root of 25 is 5. 3 plus 5 equals 8. That's a true statement. 8 equals 8. That means 14 is a solution to that equation. We're going to solve this equation for x. The square root of 4x plus 1 minus 5 equals 0. So we want to isolate that radical to one side of the equation and move everything else to the other side. So that negative 5 needs to be moved to the right side by adding 5 to both sides. If you do that, you get the square root of 4x plus 1 equals 5. Now we need to get rid of the radical signs to do the opposite of square root, and that is to square both sides. If you square each side, if you square the square root of 4x plus 1, that is 4x plus 1. And on the right, if you square 5, that is 25. Subtract 1 from each side to get 4x equals 24. And finally, divide each side by 4, x equals 6. Now 6 appears to be a solution, but you did square both sides as you're working through this, so 6 may be an extraneous solution. You want to check that back in and make sure it does work. So substitute 6 back in for x into that original equation. You have the square root of 4 times 6 plus 1 minus 5 equals 0. You can take 4 times 6, that is 24, so it'll be the square root of 24 plus 1, that is 25. So it'll be the square root of 25 minus 5 equals 0, and the square root of 25 is 5, so that would be 5 minus 5 equals 0, and that is a true statement. 5 minus 5 is 0, 0 equals 0, so that does work. 6 is a solution to that equation. We're going to solve this equation. The square root of 6 minus 3x minus 2 equals 0. So we want to isolate that radical to one side of the equation and move everything else to the other side of the equation. So that minus 2 needs to be moved to the other side by adding 2 to both sides. When you do that, you get the square root of 6 minus 3x equals 2. So we have the radical sign isolated to one side. Need to get rid of the radical sign now by doing the opposite of square root, and that is to square both sides. If you square the square root of 6 minus 3x, that would be 6 minus 3x. Whatever you do to one side, you have to do to the other side. So square the 2, and that is 4. Now move that 6 to the other side by subtracting 6 from each side. Get negative 3x equals negative 2. And finally, divide each side by negative 3, x equals 2/3. So it appears 2/3 is the solution, but you did square both sides as you're working through it. So you want to check to make sure that 2/3 is not an extraneous solution. So substitute 2/3 back in for x into that original equation. Be the square root of 6 minus 3 times 2/3 minus 2 equals 0. Well, negative 3 times 2/3, that is going to be negative 2. So be the square root of 6 minus 2 minus 2 equals 0. 6 minus 2 is 4. Be the square root of 4 minus 2 equals 0. And the square root of 4 is 2. 2 minus 2 equals 0. That's a true statement. 0 equals 0. That checks out. That works. That means 2/3 is a solution. We're going to solve this equation for x. 3 times the quantity x plus 1 to the 2/3 equals 12. Now there is a rule that applies to this. To solve equations of the form x to the m over n equals k, where k is a constant, raise each side of the equation to the power n over m, or in other words, the reciprocal of m over n. If either m or n is even, so if either the numerator or denominator of that fractional exponent is even, then x to the m over n raised to the reciprocal, raised to the n over m power, then that equals the absolute value of x. In other words, if either the numerator or denominator of that fractional exponent is even, you're going to apply absolute value. Seems confusing? You'll see it better with an example. So we're going to move that 3 to the other side by dividing each side by 3. If you do that, get x plus 1 to the 2/3 equals 4. So here we have to raise both sides to the reciprocal power. Raise both sides to the 3/2 power. So you have x plus 1 to the 2/3 to the 3/2 equals 4 to the 3/2. So we're raising both sides to that reciprocal power, and that 2, that numerator of that exponent, is even. So that means we're going to apply absolute value. So we're going to switch over to the absolute value of x plus 1. Now on the right, when you take 4 to the 3/2, that is the square root of 4 to the 3rd power. The square root of 4 is 2, so that would be 2 to the 3rd, which is 8. So we have the absolute value of x plus 1 equals 8. Now remember, absolute value means distance from 0. So this says the distance that x plus 1 is from 0 is 8. Well, there are two numbers that are 8 away from 0, -8 and +8. So x plus 1 could be equal to 8, or x plus 1 could be equal to -8. So we have x plus 1 equals or -8. Subtract 1 from each side, get x equals -1 plus or minus 8. Just take -1 plus 8, that is 7, and -1 minus 8, that is -9. Now you could check those back in. I'm not going to take the time to do it here, but if you check 7 back in, if you check -9 back in, they both work. X equals 7 and also x equals -9. We're going to solve this equation for x. 2 times the quantity x plus 3 to the 2/3 equals 8. So we want to isolate that set of parentheses just like it's a radical sign by moving that 2 to the other side. Divide each side by 2. If you divide each side by 2, you have x plus 3 to the 2/3 equals 4. Now we're going to raise both sides to the 3/2 power. So if you raise both sides to the 3/2 power, it'll be x plus 3 to the 2/3 to the 3/2 power equals 4 to the 3/2. Now that x plus 3 to the 2/3 to the 3/2, that 2 is even. Remember, if either the numerator or denominator is even, you're going to switch over to absolute value. So it'd be the absolute value of x plus 3 on the left. Now on the right, 4 to the 3/2, that is the square root of 4 to the 3rd power. The square root of 4 is 2, so that is 2 to the 3rd, and that is 8. So we have the absolute value of x plus 3 equals 8. Remember, absolute value is distance from 0. That says the distance that x plus 3 is from 0 is 8. Well, there are two numbers that are 8 away from 0, -8 and +8. So x plus 3 could be equal to 8, or x plus 3 could be equal to -8. Subtract 3 from each side, you have x equals -3 plus 8, that would be 5, and -3 minus 8, that would be -11. So x equals 5 or -11. You should check those back in to check for extraneous solutions, but both solutions work. X equals 5 and also -11.